It is my pleasure to present to you a research conducted by three key movers for smarter city concepts in one of the emerging cities in the northern part of the Philippines, Kawayan City, Isabela. Appropriate business model for electric vehicles, rapid charging in a smarter city. My name is Dr. Priscilla de Lima, a professor of biological science and currently the executive officer of one of the 9 campuses in Isabela State University, Kawayan City campus. The campus is located at the heart of the city, approximately 2 kilometers away from the domestic airport and located at the busy street of the city of Kawayan. Kawayan City has been chosen as the model for smarter city in the Philippines, being one of the fastest growing economies in Cagayan Valley. Hence, it is called Kawayan City, Smarter City. In May 2017, Kawayan City has merged a memorandum of agreement with 4 nearby municipalities. As a result of this collaboration and partnership with 4 other municipalities, the group of municipalities is now called Metropolitan Kawayan. In 2015, a MOA between DOST, ISU, and LGU was merged to develop ICT-based programs, competency building, and training on smarter cities. There are 8 components of Smarter Philippines, and these are smarter scientists and engineers, smarter healthcare, smarter farming, smarter MSMEs, smarter industry, smarter jobs, smarter government, and smarter climate change adaptation. LGU Kawayan City developed some smarter city strategies that will make processes more efficient, participative, and innovative to its people, and also plans to adopt appropriate modern transportation technology as part of the many smarter city strategies of the city. The present scenario in Kawayan City is that tricycles are the majority's choice of transportation. The tricycles are used within the 65 urban barangays and nearby towns, and there are 39 registered trike operators drivers associations. The effects of conventional tricycles are the following: air pollution, respiratory diseases, climate change risks, and health and environmental problems. There are about 4,500 registered conventional tricycles in Kawayan City, and it attempted to stage the biggest number of tricycles flying in a city and was recorded in the Guinness Book of Records. Recognizing the need for cleaner and more efficient vehicles, the government initially transformed public transportation sector by adopting electric vehicles, specifically electric tricycles. Given this scenario, the city government is interested to invest on e-trikes as part of its strategy to promote smarter city, smarter mobility in the city, as well as the adoption of an e-trike battery charging station for the successful implementation of the project. There are major components of solar e-trike for Kawayan City, and these are the chassis, the shell, the electromechanical parts, which includes motor, controller, battery, throttle, key switch, forward, reverse switch, battery management system, and grip. And the solar e-trike special features include solar panel, roof, AC charging and DC charm charging, reverse operation alarm, built-in multimedia system, LED signal lights, cooling fans, and USB charging ports for driver and passengers. The picture of the rapid charger or CHARM prototype 2 includes the charger vehicle SmartLink, 48 VDC nominal charging voltage, 5 kilowatt rated power, modular power converter design, input of about 220 VAC single phase, high power charge connector with electronic lock, touchscreen user-friendly interface, and a tap-to-pay system. The Rapid Electric Vehicle Charging or Charging Units or CHARM is developed by the University of the Philippines Electrical and Electronics Engineering Institute, funded by DOST Picture. Charge in less than 30 minutes instead of the usual 8 hours, and its battery is lithium-ion, which has a longer shelf life. Both the e-trikes and the rapid charger were piloted in Cagayan City, a Smarter City project funded by the National Government Agency, DOST. The general objective of the project is to establish the three commercialization requirements of the Rapid Electric Vehicle Charging or CHARM. Its specific objectives are to validate the type of users, frequency of use, and other market or social drivers for the commercialization of CHARM in Cagayan City, Isabela, to identify appropriate financial and business model for CHARM, and to assess the economic and environmental advantages of CHARM to e-trike operators in the city. As for the methodology, there will be a comparison of the three business models. Model 1, straightforward charging station, wherein there is a 30-minute charging time. Model 2 is the battery swapping system, which replaces discharged batteries with fully charged backup batteries. And Model 3, the automated charging machine. The concept of e-money will be introduced to the e-trike drivers. Model 1 is the straightforward charging. This model is fast charging station capable of as quick as 30 minutes charging time. It is similar to a regular refueling station where the user utilizes a CHAdeMO compliant connector to recharge the e-trike. This model involves no major behavioral adaptation on end users of automobiles during refueling and can reduce operating costs in relation to extra equipment and operation time. Model 2 is the battery swapping system. This model is usually done in a station which replaces discharged batteries with fully charged backup batteries. Ideally, the battery swapping will only take minutes by removing the depleted battery and installing the fully charged battery. Model 3 is automated charging machine. This model is a modern convenience to e-trike users. The concept of an e-money is introduced to e-trike drivers in order to use the CHARM facility. The model allows users to charge the e-trike without the use of actual money. E-trike drivers can charge and access the facility 24/7 any time of the day. E-trike drivers will adopt a self-service technology that is cost-effective in the long run. To evaluate the business case for each entity involved in the business model, three commonly used financial analysis metrics are used in this project, namely return on investment or ROI, net present value or NPV, and payback period. Each of these metrics has its own advantages and when combined, will offer a rich analysis of the financial viability of e-trike and CHARM facility and the benefits that they provide to each of the stakeholders involved. The financial performance of both the e-trikes and the CHARM facility is evaluated from the following distinct perspectives. The financial analysis metrics include the e-trike drivers when operating based on boundary systems, the e-trike drivers when they own the e-trikes that they are driving, the Isabela State University as an operator of e-trikes, and the Isabela State University as the owner-operator of the charm facility. Each of the above perspectives was analyzed with its own cash inflows and outflows, ROI, NPV, and payback period if feasible and deemed necessary. For the results and discussion, first model is a straightforward charging station. It was identified that while the straightforward charging station might be more convenient to e-trike drivers, it gives extra burden to the charm operator because of the need to employ full-time employees to man the facility and manage every charging transaction. Moreover, the first model limits the operating time of the facility to the regular 8 hours per day unless the operator is willing to employ more employees to manage the facility during the night. For the second model, or battery swapping system, the battery swapping system is not a practical way of replenishing the energy source of e-trike. When the ISU technical team employed the battery swapping system, they encountered technical trouble in the e-trike. As such, the engineers suggested to refrain from implementing the battery swapping to maintain the safety and integrity of the e-trike. Moreover, it was also identified that due to the heavy weight of the batteries, it will take about 30 to 45 minutes to swap them, which is already enough time to charge the e-trike in the fast chargers. Therefore, in terms of time and convenience, the battery swapping system provides no advantage over the fast charging system. Further, if the swapping system is to be implemented, the capital cost of purchasing additional batteries, which amounts to around 100,000 for one battery set, should also be considered. Our third model on automated charging machine. The automated charging is identified as appropriate business model that should be used for the commercialization of charm in the city due to its convenience, low cost, and high revenue potential. Under the system, the e-trike drivers are provided with tap card that they can reload and use when charging. The automated charging machine can operate 24 hours every day without any significant additional cost. Moreover, the operator can save substantial costs in the long run for not having to employ workers to man the charging facility. Based on the experiment conducted, the most appropriate business model to utilize during the commercialization of charm is the automated charging machine system because it is not only the most convenient business model but also the one that offers the highest revenue potential and lowest cost. And to finally conclude, ISU should continue operating its charm facility. Moreover, ISU can also continue to serve as an operator of e-trike for the medium term while the EV market is still on its early stage of development in the city. However, in the long run, tricycle drivers in the municipality are encouraged to purchase their own e-trike as this setup generates the highest profit as compared to the boundary system, whether when analyzed in terms of ROI, NPV, or payback period.